Welcome to Techietalkee.
Hello friends, in this video I'll be explaining about the math module in Python. So basically this module is a built-in module that helps in performing different mathematical calculations. This module contains functions and constants. So if we are planning to make use of the constants or functions, we have to first import the math module like this. So we have to give import math. I'll first walk you through the constants. In mathematics, we have come across the word pi, which is represented by n. The value of this pi is 3.141592 and keeps going. So in Python, we can get the same value generated by calling maths.py. So here I have given print maths.py, which is going to print me the pi value. This pi is one of the constants in math module. So the next one is e. This maths.e constant is going to return the Euler's number, which is 2.71828. So this constant will be used in places where we want to understand the exponential growth as we do in finance. Next, let's look at the tau constant. This is the constant which we use with respect to circles. So this value is nothing but it is 2 pi. My first print statement is maths.py. My next print statement is maths.tau. So here I am printing both the values. If I give it to be 2 into maths.py, it is going to be the same as that of maths.tau. So which is tau is nothing but 2 times pi. So these are some of the constants that we can make use of in maths module. Next, let's look at the functions in math module. So the functions at a very high level falls into 5 categories. They are number, power and logarithmic, trigonometric, angular and hyperbolic. So I'll be explaining you about some of the functions that we have in each category. So first, let me explain you all the number functions that we have in Python. We have the ceil function in Python. So what this does is it rounds the number up to the nearest integer. So in my example, I want to print the ceil of 3.2. So when I execute this code, I get 4. So what actually happens is this ceil function is going to round the number up to the nearest integer. The next we have the floor function. This floor function is going to round the number down to the nearest integer. So in this case, I have given maths.floor of 3.2, which is going to give me the result as 3. So if I give it to be 3.6, it is going to give me 3 again, which means it is going to round the number down to the nearest integer. The next number function that we have is the factorial. Here I am giving maths dot factorial of 3. So I'll get the answer as 6. So this function is going to return me the factorial of that particular value. So if I give it to be 7, it's going to return the factorial of 7, which is 5040. So these are some of the number functions that we have in Python. The next category that I'll be covering is the power and the logarithmic functions. So where I have exponentiation, square root, log and the power functions. Let's look at it one by one. So this exponentiation method is going to return e to the power of that number. So which means e to the power of 3. And as we all know, e is the Euler's number, which is going to hold the value of 2.71828. So the calculation is going to be 2.71828 into 2.71828 into 2.71828. So that is why we are getting the answer to be 20.0855 and it keeps going. Next, let's look at the square root method. If I give math dot square root of 9, it's going to return me the answer of 3. So this method is going to return the square root value. we have the log method, which is going to return the logarithm of a value. So here I am giving print maths.log of 9. So I am getting the value to be 2.19722. So this log method actually expects two parameters. One is the number for which we have to calculate the log value, and the other is the base value. So here I have given the value for which I am going to calculate the log value, which is 9. So if I don't give the base value, then by default the Euler's number will be considered for the optional value, which is the base value. So in this method, I am using the natural logarithmic value, which is log to the base of e. I can also give log of 9 comma 3, where 3 is the base value, and Python gets me the log value accordingly. So apart from this log method, Python also provides log 2 and log 10. Here I am giving log 2 of 9. So this is the value which I am getting for the log 2 of 9. So this log 2 of 9 is the same as log of 9 comma 2, where I am going to get the log value to the base 2. So as you can see here, the results of both these are the same. So log 2 of 9 is nothing but log of 9 comma 2, which is log of 9 to the base 2. Similarly, we have log 10, which is nothing but log of the value to the base 10. So the values of these two are also going to be the same. So these are some of the log functions that we have in Python. Next, we have the power method, which is going to calculate the value of x to the power of y. So here I have given print maths dot power of 3 comma 4. So which is nothing but 3 to the power of 4, and so I got the value to be 81. The next category that we are going to look at is the trigonometric functions. So where we are going to know about the cos, sine and the tan functions that are available in Python. So these three functions, which are cos, sine and tan, are pretty much what we have already read in mathematics, where it is going to get the cosine, sine or the tan value of that particular number. And in Python, these three methods are going to accept one parameter for which Python is going to calculate the trigonometric value. Apart from these three trigonometric functions, we also have some of the hyperbolic functions like cos h, sin h and tan h. So which are going to return the hyperbolic value of cosine, sine and tan. And the syntax is pretty much the same, where you give maths.cos h of the value for which Python will retrieve the hyperbolic cosine value. Next, let's get into the next category, which is on the angular functions, where we have radians and degrees. This maths.radians is going to convert the value from degrees to radians, and this degrees is going to convert the value from radians to degrees. So if I give maths.radians of 30, it's going to return me this value, and I'm just going to take a part of that result and place it here, and I'm going to convert it to degrees, which is 29.9, which is almost 30. So these are the angular functions that we have in maths module. Hey guys, hope you now understood about the constants and the functions that are available in the Python maths module.
Thank you for watching this video. If you have any queries, you can reach out to me at techietalkee@gmail.com. Happy learning and have a great day.